Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Could you please explain the concept of reinforcement learning and its role in training large language models like RLF?
Reinforcement learning, RL, is a way of training a machine learning model by allowing it to learn from its interactions with an environment. It is like teaching a child through a system of rewards and punishment. The model, also known as the agent, takes actions in the environment to maximize its cumulative reward. In the context of training large language models like RLFH, reinforcement learning is used to fine-tune the model and improve its performance. The RL agent interacts with the language model, which is the environment, and learns to make sequential actions to achieve better results. The RL agent explores different actions and receives feedback in the form of rewards or penalties based on its performance. These rewards guide the agent to adjust its actions in a way that maximizes the desired outcome, such as generating more accurate and coherent sentences. By using reinforcement learning, language models can learn to make better decisions and generate more accurate and contextually appropriate text. It allows the models to learn from their mistakes and continuously improve over time. Overall, reinforcement learning plays a crucial role in training large language models by enabling them to learn from their interactions with the environment and optimize their performance based on rewards and penalties.
That's a great explanation. I have a few more questions to deepen my understanding. In reinforcement learning, what is the difference between supervised learning and reinforcement learning? How does reinforcement learning allow for learning from non-differentiable signals and arbitrary feedback?
Supervised learning and reinforcement learning are two different techniques used for training machine learning models. Supervised learning is like having a teacher who provides you with examples and tells you the correct answer. In supervised learning, we have a dataset with input examples and corresponding labels, and the goal is to train the model to accurately predict those labels. For example, if we want to teach a model to classify images as either cats or dog, we would provide a dataset of images labeled as either cat or dog, and the model learns to make predictions based on the patterns it observes in the data. That's done. On the other hand, reinforcement learning is like learning through trial and error, where you receive feedback based on your action. In reinforcement learning, there is an agent that interacts with an environment and learns to make decisions in order to maximize a reward signal. The agent takes actions in the environment, and based on the rewards or penalties it receives, it learns to adjust its behavior to achieve better outcomes. It's like a person playing a game and trying different strategies to earn more points. So, the main difference is that supervised learning is about learning from examples with known labels, while reinforcement learning is about learning through interaction with an environment and receiving feedback in the form of rewards or penalties.
Thank you for clarifying the difference between supervised learning and reinforcement learning. It's clear that reinforcement learning involves learning from feedback and making decisions to maximize rewards. You mentioned that reinforcement learning allows for learning from non-differentiable signals and arbitrary feedback. Could you elaborate on this? How does reinforcement learning handle situations where the feedback or rewards cannot be easily expressed as a mathematical derivative? And how does it handle arbitrary feedback that may not have a clear mathematical restudy?
Reinforcement learning, RL, can handle situations where the feedback or rewards cannot be easily expressed as a mathematical derivative through a technique called Q-learning. In Q-learning, the goal is to learn the value of any action at a particular state by estimating the expected return of taking that action at the current state and continuing according to the same policy. In RL, rewards are used to guide the learning process, but sometimes these rewards may not have a clear mathematical restudy. This is where the Q function comes into play. The Q function assigns a value to each state action pair, representing the expected return of taking that action at the current state and continuing thereafter. The Q function is learned iteratively through trial and error, where the agent interacts with the environment, observes the rewards, and updates its estimates of the Q values based on the observed rewards. The key idea is that the agent can learn to associate certain state action pairs with higher expected returns. even if the rewards themselves are not easily expressed mathematically. The agent learns from its experience and gradually improves its estimates of the Q values, allowing it to make better decisions in the future. So, even if the feedback or rewards in RL cannot be easily expressed as a mathematical derivative, or have a clear mathematical residuity, RL can still learn to optimize its actions by estimating the expected returns using the Q-learning algorithm.
Thank you for explaining how reinforcement learning handles situations where the feedback or rewards may not have a clear mathematical residuity. Q-learning is a powerful technique that allows the agent to estimate the expected return of actions at each state, and update its estimates iteratively through trial and error. Now, let's focus on the concept of trajectories in reinforcement learning. The report mentions that trajectories in language models are sequences of states and actions. Could you explain what these states and actions represent in the context of language models? How are trajectories used in training large language models?
In the context of language models, states represent the current textual sequence, which is the input that the language model uses to make predictions. Think of it as a sentence or a paragraph that the language model is working with. Actions, on the other hand, represent the next token that the language model predicts or generates based on the current state. It's like the language model making a decision on what word or character should come next in the sequence. Now, when training large language models, trajectories are used to guide the learning process. A trajectory is a sequence of states and actions that the language model goes through during training. During training, the language model is given an initial state, a starting point, and it generates an action, a predicted token. This action is then added to the current state, creating a new state. This process is repeated, generating a sequence of states and action. This sequence of states and actions is the trajectory. By comparing the generated trajectory with the desired or optimal trajectory, the language model can learn to improve its predictions. The quality of the language model's output is evaluated using a reward function, which can be based on human ratings or a reward model that has been trained over human preferences. In summary, states represent the current textual sequence. Actions represent the next token predicted by the language model, and trajectories are sequences of states and actions used to train the language model by comparing it with desired outcomes.
Thank you for providing a clear explanation of how states, actions, and trajectories are used in the training of large language models. It's interesting to see how trajectories capture the sequence of states and actions, allowing the language model to learn and improve its predictions based on desired outcomes. Now, let's discuss the terms return and discount factor mentioned in the report. What do these terms mean in the context of reinforcement learning? Specifically in the training of large language models? How are they used to evaluate and optimize the performance of the language model?